So we're going to be looking at our review for logarithms and exponentials. Remember, an exponential function and a logarithmic function are inverses of each other. Now, a lot of you probably remember that we can rewrite these. So if I have b to the x is equal to y, I can manipulate this and write this as log base b of y is equal to x. Now notice the variable x is in the exponent for an exponential function. By rewriting it as a log, I can now isolate that variable. I can now solve for x. So if we're changing from exponential form to logarithmic form, I have this 4 to the 5x is equal to 8. Well, I can rewrite this as log base 4 of 8 is equal to 5x. Now, if I wanted to solve for x, I have this x by itself, and I can evaluate this part in my calculator. Now, if I have e to the 3x is equal to 9, I again want log base e, but I don't write log base e. I write natural log. And I take the natural log of 9, and again, that isolates the exponent 3x. Going the other way, if I have this natural log of x plus 2 is equal to 70, again, I have the base of the log. Well, the base of the log here is e, because that's a natural log, natural base. That's an ugly e. A little bit better. So e to the 70th power is equal to x plus 2. Again, here, when we're going from a logarithm to an exponential, the whole point is to free up this, what I'm taking the log of. And here, again, to isolate the variable, all we need to do is subtract 2. When I don't have a natural log or a natural base, here I have the base of 2. So it's going to be 2 to the 9th is equal to x minus 8. Simple. Next up, we have the change of base formula. And this is important because most calculators that we use, the TI-83, the TI-84, will only use base 10 or base e. Now, even if your calculator will allow you to change the base, you still need to know this. This is still going to be required for the exam. This step is going to be important. So if I have log base 9 of 24, I can rewrite that as log of 24 divided by log of 9. And so if you actually put that into your calculator, log of 24 divided by log of 9, you actually get we could say 1.45. Now, it's important to know here that if you do the log button in your calculator or the natural log button in your calculator, it's going to give you the same decimal because this, this change of base will work with any change of base. So I could change this to log base 20, and it's still going to give me 1.45 because that's the value of this expression. Next up, we have log base 8 of 7. So I do log of 7 over log of 8. Notice what I'm taking the log of is up top, and the old base is in the denominator. So again, I have log or natural log of 7 divided by log or natural log of 8, and I get 0.94. We're going to have a long decimal so we can round. And finally, log of 5 over log of 6. So we do in the calculator log of 5 divided by log of 6, and we get 0.90. We actually get 898, but we round appropriately to get 90. Okay, moving on. We're condensing. When we condense, there are 3 properties: the power property, the product property, and the quotient property. When we are condensing, we always do the power property first. So here I have natural log of 3x plus 4 natural log of x. So this actually becomes natural log of 3x plus natural log of x to the 4th, because I use this power property first. And then I can write this as a product. So this is going to be the natural log of 3x to the fifth, and that's my final answer. Similarly, if I go down here to C, we want to write this as a product because we're adding these two logs. But first I need to do the power property. So this actually becomes log base 9 of 4x plus 5 plus log base 9 of x to the fifth. And then because I'm adding these two logs, I can write this as a product. And actually, I shouldn't put an equal sign there. And this leads to log base 9 of 4x to the sixth plus 5x to the fifth. That's my final answer there. Now, when I'm subtracting, that's going to give me the quotient property. So again, I'm condensing, so I need to do the power property first. So this is actually going to be log base 7 of 2x squared minus log base 7 of 5. This 2x squared is actually 4x squared because this 2 distributes in. And so I'm left with log base 7 of 4x squared divided by 5. It's divided by because this minus sign means I'm having the quotient. And finally, same deal here. I need to do my power property first. So this is natural log of x to the eighth minus natural log of, again, this 3x is going to be in parentheses. So I'm raising both the 3 and the x to the fourth. So I get the natural log of x to the eighth over 81 x to the fourth. I can simplify this further because x to the eighth and x to the fourth can be simplified. So I get natural log of x to the fourth over 81. Okay, so that was condensing logarithms. But when we expand logarithms, it's a little bit different. We don't have to worry about the power property first. Now here, for letter A, sorry, A is a letter. For letter A, we don't have any properties to use first, so we actually have to use this power property first. So I do that, and I get 2 log base 5 of x plus 5. And that's actually it. This isn't a product, so I can't separate these. It's not a quotient, so I'm done. Now, for letter B, we can see natural log of 6x to the fourth. It may be tempting to do the power property first. However, this 6 is not raised to the fourth power. So I actually do need to separate these using the product property. And I write, since this is 6 times x to the fourth, I write this as natural log of 6 plus natural log of x to the fourth. Now that these are separated, I can use the power property and do natural log of 6 plus 4 natural log of x. Next up over here, same thing. I have this quotient, so I'm going to write this as a difference of those two logs. Natural log of x to the eighth minus natural log of y to the sixth. These powers become coefficients, so I get 8 natural log of x minus 6 natural log of y. And I'm done. D, same deal. Now, watch what happens with D. So with D, we get, first off, this quotient. So I get log base 9 of 5x minus log base 9 of 9. But look at what happens. This is actually a product. Don't miss this. This is going to be log base 9 of 5 plus log base 9 of x. Now I subtract log base 9 of 9. But when what you're taking the log of is the same as the base of that log, it just equals 1. So this is my answer here, log base 9 of 5 plus log base 9 of x minus 1. So be careful with that and make sure you don't just rush through this and miss something important like an extra product rule or this identity. Next up, we're going to be solving some equations here. So actually, I did not give myself a whole lot of space here. So I'm actually going to expand these problems out one at a time. That was really loud. Okay, so these are the problems. Sorry about that little delay there. And let's go through and solve these. So if I have problem A here, I know that I want to isolate this variable x, but in order to do so, I need to isolate this natural log of 3x. So I subtract 9 from both sides first. I get that the natural log of 3x is equal to 6. And don't forget, we can rewrite this as e to the 6th is equal to 3x. And then x must be equal to e to the 6th divided by 3. So in my calculator, I can do e to the 6th and divide that by 3. I get that x is about equal to 134.48. Nice little algebraic maneuvers, and I let the calculator do the rest. For b, same deal. I know I want to take the log of this, but I can't do anything until I remove this. Now I could use a product property, but it's actually probably going to be easier for me to just divide by 4 first. So I get e to the 5x is equal to 12. Rewriting this, I get that the natural log of 12 is equal to 5x. So x must be equal to the natural log of 12 divided by 5. Now, it's important to note here, this is not 12 divided by 5, and then you take the natural log of this. This is natural log of 12, and then you divide that by 5. And so this gives us that x is about equal to 0.50. If I'm rounding to hundredths, I'll keep this uniform. 0.50. Okay, C. Again, we could use the power property, but that's going to be a mess because then we have to multiply this out to the 6th power. So instead, what I'm going to do is I'm going to divide both sides by 6. So I get log base 2 of 2x minus 3 is equal to 3. Now I get 2 to the 3rd is equal to 2x minus 3 just by rewriting this. Well, 2 to the 3rd is 8. So I get 8 equals 2x minus 3. I can add 3 to both sides, so I get 11 equals 2x. So x must equal 11 divided by 2. No calculator needed for this one. Now here, this is a little bit tricky because I actually have 2 exponents. So I can't take a log of both sides because then there's still going to be 1 log. However, I have this 16. This base over here is 2. Maybe there's some way to write 16 as a base of 2. And if you remember that 16 is really 2 to the 4th power, then you can rewrite 16 as 2 to the 4th, and it still has this 5x. The right side stays the same, and here I can multiply these exponents. But notice, look, if the bases are the same, the exponents must be the same as well. So I get 4 times 5x, which is 20x, is equal to 2x plus 9. There are no exponents anymore. There are no bases. I'm just looking at the exponents. So I can subtract 2x from both sides, so I get 18x is equal to 9. Divide 18 on both sides. I get 9 over 18, or 1/2. It was a nice one. e, all I have to do is rewrite this. There's nothing to divide. So here the base is e, and I get e to the 6th is equal to 4x minus 9. And so that's going to give me e to the 6th, which is 403.43, is equal to 4x minus 9. And then if I just add 9 and divide by 4, I get that x is about equal to 103.11. And finally, I have this. Now, I could write this as, I could take the log of both sides. However, this is something just like the previous problem we did on D, where 49 is actually 7 to the 2nd power. So if these bases are the same, I can set 5x plus 2 equal to 2. And then here I get that 5x equals 0. So x is equal to 0 divided by 5, which is 0. And that's perfectly fine. Next up, I have log of 4x is equal to 9. Don't forget, when I don't write the base of the log, this actually means that it's base 10. So this is 10 to the 9th is equal to 4x. So this is going to be a really large number. And then if I divide this by 4, I get that x is equal to 10 to the 9th over 4. So x is going to be equal to this large number. $250 million. Yes, 250 million. A lot of zeros. All right, finally we have this. If you have the natural log of a and that equals the natural log of b, then quite simply a equals b. Now you could raise both sides as exponents to base e, and then the natural logs and e's will cancel out. But if you just recognize this, you can solve easier. So I get 2x is equal to 14. So x is equal to 7. Plain and simple. So those are the problems there. So if there's anything you need to focus on, make sure you note it on the sheet. And good luck studying.